Hi everyone, I'm Wojciech Blaszak, a software engineer from Siili, a company that is the Qt's premium partner. Together with Qt, we often all work on HMI development for automotive platforms, also those based on Android Automotive. This is why today I will share with you some thoughts and details about the Qt for Android Automotive, a new addition to Qt framework, which deepens integration with this new platform. The subject of my presentation is about coding with Qt for Android Automotive. But in fact, there wouldn't be much of code writing here, as we do a lot of things to automate as much as possible. And how to achieve that, what concepts and solutions are behind that, this will be also part of this talk. This is our agenda. The presentation is divided into 5 parts. First, we'll talk a little bit about the architecture of the Android Automotive OS to get to know the background. Next, we will see how interaction with the Android car API looks like. So how we can access the vehicle data. The third part, I will describe the approach for code generation in Qt for Android Automotive. Next, we will put all those pieces into one big picture to see the overall workflow. After all, I will talk about new module from Qt for Android Automotive, which purpose is encapsulation of vehicle properties mapping and offer a convenient way to integrate the car API with Qt application. This module named Android Vehicle Properties. Okay, so let's start with our background. So the Qt and Android Automotive OS. From one side, we have the Qt framework. It's a well-recognized in software development for automotive industry. It is used for implementation of HMI or IVI, instrument cluster, head-up displays, and so on. It is adjusted and tailored for requirements and expectations of software development process in automotive. On the second side, we have the Android OS, which is a global leader in mobile devices. It has a well-defined architecture and consistently adapts it to the new challenges, like now the automotive. But Android is having own philosophy. And when we doing the software for Android, we need to accept it. It is related to security policy, multitasking, UI composition, drawing, interaction with system, and so on. And now let's talk about Android Automotive, the additional feature added to the generic Android OS, dedicated to vehicle-related functionality. OEM and hardware vendors got huge benefits when switching to the Android Automotive, because they don't need to put as much attention to development of the operating system and hardware abstraction layers. And they're receiving feature-rich middleware and services, but also the third-party apps. And of course, there is also Google services like Maps or Play Store. But due to serious differences, migration to the Android is difficult, or sometimes even impossible. In that situation, you need to create your UI and the backend from the scratch, rather than reuse already done solution and port to the new platform. But in a while, we will see how Qt for Android Automotive solves this issue. Okay, let's now take a look on the Android Automotive OS architecture. On this nice diagram from Android documentation, we can see the high-level overview of the Android's car API. So the interface for interacting with the vehicle data. What is easy to be noticed is clean division of who is responsible for providing each of the system's components. So Android provides the interface to the car API, which is implemented by the Android car service and interacts with other Android system services. It also defines the interfaces implemented by the OEMs or their tier 1s for the vehicle hall and other halls, which can be delivered as a BSP for the target device. We can see also the third-party apps, but this is beyond the scope of this presentation, so let's focus on the interacting with the car service. How such interaction can look like is depicted on the following diagram. Let's assume that our Qt application is using Qt car service, the specialized implementation which is in the middle between the Android's car service and the app. Such Qt service is our bridge to the Android's world, our abstraction of how to talk with this new guy here. So our Qt car service hides the Android's details and passing the request and response between the Android car service and the Qt application. In this particular example, we see whole round trip of the air conditioning status, which application was asking for. In that way, we would receive the vehicle data. The Qt application is asking the Qt car service about the requested AC status. Qt car service passed the request to the Google's car service through the JNI. Google car service requests the vehicle to get this AC status, and the vehicle gets this data from the electronic control unit. And the air conditioning status is getting back to the Qt application in the same way. So from vehicle to the car service, from car service to the Qt car service, and from the Qt car service to the Qt application. Now let's design the structure of our application. How can we decompose it? We can distinct the UI part, which will be defining the QML. It can be created with the Qt Design Studio and know nothing about the vehicle data interface. You shouldn't care about that. Then we can define the Qt application in C++, which will be responsible for the separation of our UI from the data model and attach the bindings to the backend and to connect the services. We can have a mock backend for test purposes, or we can use, for example, Qt remote objects for cross-domain communication. And finally, we can use the JNI backend for direct communication with the service in Java on Android side. And that way, we can do the calls to the car API. We will use standard Qt support for Android, which is mature and well known, so I wouldn't elaborate on that part because, in fact, we've got it out of the box after doing the Qt framework and Qt creator setup. But now let's think about how we can do this solution more scalable. I mean, in real case, we have many features, applications, and vehicle properties. The answer is Qt Interface Framework, formerly known as Qt IDI. This solution for middleware implementation comes with the tools for code generation with clean pattern of API separation for the front end, which exposes the feature to the application, and the backend, which is accessing the proper services. There is also core implementation responsible for finding the correct backend to plug in. Templates used for code generation are completely open for modification, so can be adjusted for expected shape of the code on output. And that was exactly what we were looking for. And Qt for Android Automotive is based on this framework. In fact, it extends the Qt interface framework with new templates and filters, adjusted for Android Automotive car service. Like we can see on this picture, the yellow part is the code generator from Qt.if and the templates from the Qt for Android Automotive. Then we deliver the interface definition in QFace IDL format with annotation in YAML file marked with the pink color. Based on that, we have generated out the 4 components on output. The QML plugin that registers new types in the Qt Quick application, the front end, which exposes feature interface to the application, the backend, which implements feature interface, and finally, the service implementation. All this stuff together with the UI definition and assets is back to the APK, which can be deployed on the Android Automotive operating system. Qt for Android Automotive comes with reference applications and examples that shows how to utilize this approach. But let's take a closer look on the configuration files. Here on the white rectangle, we have a definition of the HVAC AC on property. We'll use here the climate control feature and its air conditioning status of the AC on vehicle property. We define it in the IDL file in human readable format. It defines the data type, but also Android specific permissions needed for this particular property. In the YAML file, we also define additional information about the VHOL ID, which reflects the ID in the VHOL interface definition from Android Automotive, and the zone mappings. So now let's look on HVAC application delivered with the Qt for Android Automotive. As an example, how we can utilize those components. It shows the real use case in the climate control. So we see here nice UI made with Qt Design Studio. The QML plugin and frontend expose the feature interface to the UI in QML. Then the communication goes through the proper backend to the Java service, which finally makes the calls to the Android Car API. When we put all these pieces into one workflow, then we could see the diagram like this one. You can imagine the efforts of different teams like UI designers, HMI developers, platform developers, hardware engineers, and system architects. All those efforts can be joined under one toolchain, which generates the package for our HMIs. Each work can be done independently and in the flexible iterations. What else could we improve? Well, we still depend on the car API interface. Our applications still rely on this, and changes on that area affects our application. How could we handle that? The Qt interface framework Android Vehicle Properties module is answer for that need. It separates the Android Automotive interface definition from the application. Whole mapping is defined in the module configuration and made in the QFace and the YAML files. So UI can rely on quite independent API, where changes on the Android side doesn't need to impact the UI. So let's consider once again our case with air conditioning status, where we want to access vehicle property that reflects the value. The flow of data is exactly the same, but the structure of the application will change. We will use generate components of QML plugin and backend being the parts of vehicle property module to expose the vehicle properties to the UI made in QML. And Qt Car Service will be responsible for communication with the Android Car Service. So all this communication will be exactly the same, like previously described. But from the application structure, this solution is less dependent regarding Android Car API. And integration with the application is much simpler. Now let's take a look on how Vehicle Properties module is integrated with the QML code. It is a simple import statement in the first line of this snippet. Then we define the HVAC item with climate control as ID. In the code, when we want to access the current value of the property, we just use its ID, like climate control in this case, and directly call the property name like any other registered value. So in this case, text label will be changed according to the changes of AC state. Of course, this is a simple case without playing with the zone mapping. It makes this situation a little bit more complicated. What yet we need to do is to integrate this module with the project. We can do this in one of two ways, using the QMake or the CMake. In case of QMake, present on the left side, we're just adding the proper module to the Qt variable of the profile. So the IF Android vehicle properties and interface framework. If we are working on the Qt 6, for Qt 5, it's slightly different, as we need to use Qt IVI in place of the Qt IF. And the CMake case is presented on the right side. So in the CMake list file, we need to find those two packages, interface framework and IF Android vehicle properties, with the find package function. And then add those two into target link libraries section. And that's it. That is also all what I prepared for today's presentation. So thank you for your participation. If you have any questions, you can ask me those on the chat, and we can continue the discussion in the speakers lounge, where I will be for the next 30 minutes. Thank you.